Everybody, here's a quick preview of what the piano project will look like when we're done.
That's about it, and that's in the wrong key.
If you find that you enjoy the video, I always appreciate a like or subscribe at the bottom of the page. Hope you guys enjoy. Before we get started, you can download the images for both the piano and the key in the upper right down below, or there's also an option of downloading the entire piano beginning scenario that just has the size and the images connected and the size of the world already put in there. So I'll show you how to open up the scenario if you decide to download the piano scenario. So I've downloaded the folder that is a zipped file that is below, and now I'm in my downloads folder, and I can right click and extract all. Once I do that, that will take a second to extract that zipped folder, and then that zip folder will turn into a regular folder that will have all the info that was zipped and compressed inside of it. And you have your start of piano project zipped here. I would right click and extract all from that, and once this is extracted, I'll show you how to do that, and that will bring it to the same folder that I'm currently in. And I just go to piano 1 and I click it open, choose the Greenfoot project, or now I can access it from Greenfoot if I want to try to open a scenario in there. And we have the start of the piano project. If you have any issues downloading the piano scenario, you can also just download the images and then put them with the corresponding subclasses that have already been created in the downloads, but it's pretty quick and easy to also do that.
We're going to start on the piano project, so open up piano 1 and be sure to save as your own custom piano. So I'm just going to call it piano game. Okay, in this piano game we'll have some images already saved in there, but as you can see, there is not much of any code in there, just ready for us to get started with it. So this game was created originally by the author of the Greenfoot textbook. So if you ever want to buy the textbook and get a little bit more information in Greenfoot, Michael Calling is the author, and this is the piano project. So the first thing we need to do with our piano is we need to build the piano. And in our piano, in the past, we've possibly just wanted to add in these objects right next to each other and try to make a piano that looks, pretty close together, and then save the world and all this other stuff. But that really is not the proper way we need to create this game. We want these to be perfectly even, spread apart, lined up exactly right next to each other. So we are going to learn a new concept, and that is going to be a loop. And there are two types of loops. There are for loops and while loops. For loops is normally considered the counter loop. So if we created a prepare method that will build our world for us, we can call prepare into the constructor, and this will not return, no return type. Here, our prepare method will just add in our objects. Okay, so we need to create a loop, and so there's a for loop, which is considered our counter loop. It's when you know how many times you want something to happen. And in the first portion of our loop, we would want, and this would be your starting point, we'll call it. And then in the middle, you're going to have your condition, and this will happen a certain number of times. So you'll start equaling, let's say 0, and you're going to say, while this loop is less than 12 in our example, so it starts at 0 while it's less than 12, we are going to do this statement, and then at the very end, this last part, you need to imagine it happening at the very end of the loop. So right after the statements, you have the increment or decrement. But that is going to be located right up top there. Okay, so let's create this loop here. So keep that up there just for a reminder. So 4, we'll have int I, and that just is the number of instances that have happened in the loop. So it's happened 0 times so far, and so that's a common one to start with. And while I is less than 12, we will go up by 1 each time. But when I is less than 12, remember, that's when we go down and do the statements. Okay, so in the curly brackets, we need to do the statements that we want to do. And we are going to need to create a reference to key equals new key. And then we are going to add objects key at certain positions. Okay, so our object key would need to be at, and I've already looked this up, 54. And then we want it to be at about 130 for the Y value. Okay, now we have our first key there. It's lined up pretty good. The problem is we have all of our keys settled right here. Now we want them perfectly distributed evenly all the way across. And so the way we do that is we multiply a number by I. So we're going to add I, which starts at 0, and then it'll go through the loop and add an object key. It added at 54. Then I is 1, and then it adds at 55, and then I is 2. So it'll go through this loop, and it'll happen over and over and over again, increasing I every time. And when I is not less than 12 anymore, it will exit the loop. So right now, it'll happen 12 times. So if we can manipulate I and change the X value based off which one we're adding into the world, and this is very common, manipulating I like this. So I at 0, our key will be 54. And then we'll come through the loop and we'll add another key, and I will be 1. And so 54 plus 63 is 107. And then I will be 2, and that'll be 126. And plus 54 will be 180 for the X. And so let me show you, and it'll go all the way across until I is 11 the last time through. And that'll be, what, almost 750. Okay, if you do 11 times 63 is, 696 plus 54 is about 750. And so you'll see here, we have different keys. When I is 0, it'll be 54. Then the next key gets added in. Then it'll be 117. Next key, 180. And so on and so forth until the last key is at 750 something. Yeah, 747. Okay, so now we have our keyboard laid out, ready for us to start creating. So we're going to go into our key. Now our key class, we want to create a constructor because we are going to have each one of these keys have different property attribute values. So each one of these keys needs to be a value on the keyboard. So this would be A, S, D, F, G, H, J, K, L, and so on and so forth. Okay, and so we are going to keep adding a value, string value for each one of these. And we're also wanting to have them have a different sound that are associated with each one of these keys. And so what we need to do is when first we go into key, and we are going to say our key needs to have different attributes, what we were just talking about, different fields. So we're going to have a key name that we're going to have to give each one of the keys that we add in. And then we're going to have a sound file that we're going to have to give each one of these values. Okay, and so we add that in. Now, there becomes a problem quickly in our piano because when we're adding in these keys, they don't have a string key name or a string sound file. So if we compile, there is an error because it needs a key name. Okay, so if I push G down, that'll be my key name. And then the sound file, we would need to check our sound files. So we would have to look in our piano game and look at the sounds that we have. And 3a.wave, we'll do that one, okay? So that will be our sound. So our key will be G and our sound will be 3a.wave. And we have specified that those need to be string values. So it honestly, at this point, we haven't put any code in. So this won't change anything just yet, but we are giving a placeholder for the G and 3a. And so when we go into our key, now we have a value for a key name that is stored as G for all 12 of them, and the 3a.wave for all 12 of them as well. So we need to create a way for our key class to be able to receive this key name and this sound file that we have given it. So these are connected to this object, but they are not connected and referenced from the key class. The specific objects can see the keys, but the entire class can't. So the code that is going in the whole class cannot see this key. Okay, so we need to create a way for it to see the key. So we are going to create a string, just key, and a string sound. And so we are going to set our key, our local variable key, equal to key name. And our local variable sound equal to sound file. Now, because these are strings that get entered in, so now that our G and our 3a.wave are set for each object as their key name and their sound file, whenever we plug key in the rest of the way, it will be receiving whatever is plugged in here, and for the sound it'll receive whatever is plugged in here, which right now is just G, but eventually we're going to replace this G with every key on the home row, on the middle row of the keyboard. And so that way you'll be able to type in the letters and it will receive different letters. So right now key is set to basically G, because we did that in here, and our sound file is set to 3a.wave. Okay? So we're going to need to create a way to say that the keys are pushed down, and we're going to need to create a way to make sound. Okay, so if we have a public void key pressed, we'll say if Greenfoot dot is key down G. If the G key is down, we are going to set our image to white key down .png. So this is a file, and make sure this is a string, that this will access our files in our folder. I've created this white key down folder, and this set image will use the white key down image that we have. We set image and look at our images. We have black key down, white key down, and we'll eventually add black keys onto this keyboard. Okay, and then the background. So now, if Greenfoot dot is key down, the image should change. Okay, now it's stuck. It does change, but it's stuck. So we need to say, create a Boolean is pressed. So that'll be false, and is pressed is false. You can just put an exclamation point at the front of that. They'll know. And now we're going to have multiple lines in this if statement. And so we will change is pressed from false, because the default is false, to true. Okay? And then when we push down, quickly show you, it still won't switch back, but it's ready to switch back, and I'll show you what I mean right here. So if Greenfoot dot is key down, so G is not pushed down since we have the exclamation point, and is pressed is true, so you just need to put is pressed. We're going to set our image to white key dot png. And then we will set our is pressed equals false. Okay, now if we push G down and let go, it switches back and forth, and you can put on a good light show right there. But we need to have some sound come out. So first I want to make sure I got some sound on my screen here. If we go in here, we're going to need to public void play sound. And we will Greenfoot dot, and you can do control space to see Greenfoot does have a play sound feature. And so our play sound will be sound. And excuse me, our sound will be 3a.wave in quotes because it is a string. And now play and put it in the act method. Excuse me, don't put it in the act method. We're going to put it if, because I would do it over and over and over again. We want to do it if is key down G and is press is false. Just do it once. So if you notice there, there was multiple keys that were getting pushed at multiple times, and it kind of was a little bit slow because we're trying to do all of these keys all at once. So they obviously all made that sound. And so what we want to do is make it so that this value changes for each one of these keys that we add in. And so instead of having to go in and hard code 12 keys, I mean, what if we wanted a whole piano and then we wanted a gigantic multi-level piano? I mean, it would just take forever if we kept trying to add hard code keys in. And so as of now, it is just equal to G. And so since we are accessing these parameters, we want to switch these to key, and then play sound should just play not 3a.wave, but sound. Now, this will still be G and 3a.wave, and I want to make a point of that. So when we push G, it's still 3a.wave, and G is pushing for all the sounds. But that is because of what we have in here. Okay, so in our world class, when we add these objects in, each one of them have a value of G and 3a.wave. We are going to have to create what we call an array. And an array is the ability to store a group of values, a list of values. So this array will allow us to store multiple values for this location. And so we'll have a list of 12 different strings, which are all the keys on the keyboard. So A, S, D, F, G, H, J, K, L, semicolon, all the way through. And this will give us the opportunity to store multiple values. So we're going to do public string, and so we don't have to have public necessarily, but it would be nice if this was accessible for multiple classes. But just to prove that you don't need it, you can do string, and then to show that it will be an array, you need to have these brackets without, not curly brackets, just regular brackets, and you need to name it. So this will be our key names, and then that will equal, and you put a curly bracket to start, and then you can just create a list of strings, and that will be all the way across our keyboard. And our 11th will be bracket. We'll have to go up and to the right for that last one. Okay, so then we need a semicolon at the end, signifying the end of our string. And then we're going to also need a string for sound files. And the sound files are shown. So I have the name of all the sound files here. I'm going to do the dot wave down when we actually are plugging these in. And so I'm just going to have 2A okay, then you close it off, semicolon. We have it full. It looks a little more like this. So now we have different variables here, or different values, excuse me, for our string key names. And so key names has 12 different values here, and the key names at 0 would be A, and at 1 it would be S, and 2 and 3, 4, 5, all the way up to 11. This is called the index, and the value of this number inside of key names will have to be written like this. So if you wanted to get the A, you'd have to write key names 0. So this key name 0 would say, oh, I want the A, I want the 0 spot for the key names array. Then if it was 4, I would go 0, 1, 2, 3, 4. Okay, it's G. So if I put key names 4 here, names 4 here, it would still work for G. Okay, but that's not what we're looking for either. We want this to be every single key, and not just that, we want it to be going across the screen. And so our furthest one to the left needs to be A, and then the next one in should be S, and then D. Well, we already have that set up. So when I is 0, that is the location I want my A key. Right here, right on this first one should be the A. And then for S, it needs to be the second one, which the second key happens to be when I is 1, and so it's 54 plus 1 times 63. So that goes on and so forth. So each one needs to be each value in here. And so it works very well in this example that you can just plug in I here, and A at 0, the first time through the loop, key names I will be 0, so it will grab A, and it'll put the A key at 54. And then the next time through the loop, I will be 1, so it will grab S, because I would be 1, so it would grab S. And then we'd add in the S key name when I is 1, so 1 times 63 plus 54 is 117. And that would go on and so forth, all the way down till the last one, That's a common error. Array index out of bounds, exception 11. That just means it has gone outside the bounds, the boundaries of the array that you've created. So somehow we've messed up. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We need a 12th key. That's our problem. Okay, so that'll be the right bracket. Now we compile and we exit out of this. And our loop is made. So if I push like L, it'll make the same noise, but L was this one, right? This one is L, still through a dot wave, but my X value is 558. And that is because L is 0 when I is 0, 1, 2, 3, 4, 5, 6, 7, 8. So the 8th key that they add in, I is 7. 7 times 63 plus 54 is that value that we just got. I forgot, 550 something. And it will be, I will be 7, so it would be 0, 1, 2, 3, 4, 5, 6, 7, excuse me, 8. So this would be 8 times 63. And now we can get all the keys on the keyboard, but if you notice, it's the same sound going along. Okay, so now we need to do the same thing with the sound file. And we have sound files. And that will want to match up. 2A should be the first spot in the array, or the 0 index. So when sound files I, so when it's 0 the first time through the loop, it'll be 2A, and it'll be I for the key name right here. So this would also be 0. Okay. Now we don't want just a white key down. Okay, we also want to have a different state. So fields that we put in here can represent different attributes that the key object has, and also the different states that it can be in. So we are going to have a new state that it can be in that will be the key getting pushed down, or the key not getting pushed down and the key is up. So key will be up image, and then we're going to have our down image. Okay, and this up image and down image will need to be saved in. And so we're going to have a white key and a black key. So we just want a general, if no key is pushed, the up image will be for all of them. If a key is pushed, we want to change it to the down image, whether it's a white key or a black key. So these are the states at which our keys could possibly be in. Okay, and so what this does is makes it so that we need to be able to save, just like we did with the key names in the sound file, we need to be able to save this to the class. These objects are going to be able to get the up image and down image. But is our class going to be able to save it or access it or store it? No. Okay, so once we add in, so we need to go back in, and this key name, when we add this key in, there's going to be an issue. They have 1, 2, 3, 4 strings required, but they found only 1, 2 strings. So they differ in length. Okay, and the problem is that we want the white key, the white key up or the white key down, up image. So white key up dot png, and then white, I think it's just white key dot png, not white key up. So white key dot png, and then we need the white key down dot png. Okay, so now the two states that the key is going to be in is either up or down. And that way, when we have string up image, we'll save it as the same name, and this will be a little bit confusing, but it also explains something here. So our up image will equal our up image. So how are we going to clear this up on which is which? Okay, you can reference this specific object, the specific object that you're in, and do this dot up image will equal up image, and that way when you reference it in the class, it'll know which up image you're talking about. You're talking about this up image. Okay, and then this, is going to be down image when we push down, and this will be up image. Okay, so we need to do the same thing with string down image. This dot down image equals the parameter down image. Okay, so here we could have just named this something different, but this dot up image and this dot down image is evidence of using the this keyword, which is nice to know. Okay, and so down image and up image. So this should have the same experience that we had before. So this needs the plus dot wave. And now you have different sounds. So let's test that out. Okay, so the keys are a little bit off on the actual notes, but I will edit that at the end. So just hold tight, keep it there for now. It's still making different sounds, which is great. So the white key.png and the white key down.png makes it so that these should not be hard coded in, because now we're able to do something else. We're able to make black keys, so keys that are a different image that work have slightly different values but work in the same way. So we don't need to create a new class called black keys. We can just use our key names and sound files, and the image, instead of it being a white key.png, we'll make it a black key, and a black key down image to change the state of our new key objects. Okay, so we are going to create a second for loop and have int I equals 0. And what we're actually going to do is we're going to reference the length of the key names. So I is less than key names dot length, and then I plus plus. Okay, so you could actually go back and do that now, and you could do key names dot length, and so this will be 12 because there are 12 strings in the array, and so this grabs the length of it. And this is common with loops to start at 0 and do less than the length of something, because that will grab index 0 through the last index in the array. So that's very common to find the length of the array. Start at 0 and do less than the length of the array, because that means you're checking every single spot in the array, and that's what we're trying to do here. So when we're adding in the black keys, we're still going to create a key, but we want to make it a different variable name. So we're going to, B key is going to be a new key, and we need to create a new array with different sound files for our string black keys, and this should probably be white keys instead, and this should be white key sound files, do white key sounds, and black key sounds. Okay, so this would be still, white key sounds, white keys, and we're back to it. Okay, so when we add in these keys, they need to have a different image and image for being down. So it will still be black keys because we want different buttons to be hit in order to reference them, and so we need to finish the array here, and we will add in U, I, O, 5, 6, 7, 8, 9. Let's do, and we're running out of letters. So we're going to end it there. Okay, and we'll make 8 keys here. Don't forget the equal sign. Okay, string black key sounds, and I will add in the sounds here in a moment. 3A. Okay, so the key names, it should not be key names dot length. Now it is going to be white keys dot length and black keys dot length. Okay, so this would only go up to 9, and it would start at 0 and actually end at 8. So that would be 0 through 8, so that would be 9. And we're going to do black key sounds I plus dot wave, comma, black key dot png, comma, black key down dot png. Okay. Quotes, parentheses, semicolon. Okay. So we've created it, but now we need to actually add the object in. Similar to what we did here. B key, comma. And we're going to add it at 54 plus I times 63. We're actually going to start at 86, not 54. Comma 86 here as well for the Y value. Okay, but we don't want our black keys to always show up, and we want to make sure the up image and the down image are getting pushed. So let's go ahead and test what we have so far. So if you play, oh, these turn into black keys when we play them, but we could not open file .wave. Did we forget the .wave on this? Also, I have changed the values up here for the white sounds and the black key sounds to get the correct strings in there, the correct files. Okay, so we need to make sure this .wave is done correctly. Looks like it is. Here's the problem. There's no blank .wave, so there's no nothing .wave. So we need to only add this in because we want some spaces in our piano. The black keys are not on after every single. So we're going to say if our black keys I, so if the black keys that we've chosen in the array does not exclamation point equal null blank, then we will then add keys in. So only once this does not equal the space, that's the only time we'll add the keys in. Black key sounds, that's what we need to check, if that is equal to nothing. Okay, and so now we have our spaces. R doesn't do anything. Cool. So we want to add one more in at the end. So let's add after. So let's change our piano up a little bit. So instead of this one having this up bracket, let's have it be just the quote. And so that'll be right beneath it, and that'll be on the same line, and then we'll go up to the very last white key on the end, and then we can add in a black key. That'll give us one more. That'll be a bracket, and then we can add in another sound for it, and that can be 4F sharp, and that will close us out. Now, this air out of the way. We have one more on the end. And that gives us a pretty full piano. If we want to add in more pianos on the end, and we actually would want a blank here. So we actually kind of want a blank and then the 4F. So we're going to create two more. So we're going to have this be nothing, and then give a space also here. And that will make this not show up because there is also a space in this spot in the array. And then at the very end, we'll do that close bracket or open bracket right there. Okay, so now we have now why is it turning? Why isn't it starting? So we would need to look at when our key gets entered in. So in the constructor, that's right when the key gets entered in. What is happening? Well, our up image will always start at what it sees at the top, sees first. And what it sees first, what it reads first is these white keys, and it adds in 12 of them. And then it goes to the black keys, and it will add in the black keys, but the up image starts off equaling the white key. So we need to make sure that the up image is set. We're going to set our image to our up image, grabbing that from this code right here. And then now it starts out from the beginning equaling the correct key. Okay, and actually it knows that up image cannot be accessed directly. We want to make sure up image is counted in right there. Okay, and then we have our I wish I knew a song. That's about it, and that's in the wrong key. So I hope you guys enjoyed this.
If you felt like it was beneficial to you, I'd appreciate a like and subscribe. If you felt like this video you followed along pretty well, the next video you would do is the Frogger game right up here. Or if you felt like you could use a little bit more practice on some of the more beginner topics, you can go and start the 6-hour course from the very beginning. So thanks for watching. See you next time.